Okay, are there any questions? Okay. And what part is confusing? Accepts. IDK, I know we're one of the agencies. So if you look at the description right here, it says accepts those that end with either an A or C. That begin and end with an A or C. All right, so that should explain the answer, right? So it starts and ends with an A or C, and then this happens to be the same A or C. But I guess maybe this part is the confusing part, so we could do that. Okay. So let's look at the tape. We have Q can go to T, and that can also go to Q. So this is my L diverge. T has a loop back to itself, and then it can also go to S. S can go to P or X. And then he also just goes to X. X is our L accepts. So we need to write two separate expressions or figure out what this is. Right. So we have two different paths. We have path number 1, and then we have path number 2. Right, so let's start with the green path. Start with the pink path. Yeah. Okay, so we're in state Q. Let's get rid of this. This isn't actually a loop. Okay. So we're in state Q and we have 3 transitions. All of them do something different, right? If it's an A, it turns it into a capital A. If it's a B, it turns it to a capital B. If it's a C, it turns into a capital K. So I'm gonna write A or B or C, and then figure out if the capital letter here matters. Right, I'm gonna leave a terminal symbol here, just some random symbol, but this X will determine whether or not it's a capital letter. What capital letter? So let's say we saw one lowercase letter, replaced it with one capital letter, and we moved to state T. State T is a loop, right? This is a TATAR, TB, TBR, TC, TCR, which means this is an A or a B or a C star. Right, so all of these characters, doesn't matter how many, they're all from this loop, this star. And then eventually, if I'm in state T, I'll see a blank. When I'm in state T and I see a blank, I move to the left and go to state S. Right, so state S is now looking at the last character here. Right, remember I want to go to state P. So this last character, in order for me to go to state P, needs to be an A or a C. So there has to be an A or a C here, and this character here. Right, because only n state S and A or C will take me to state P. Right, and then in state P, I have PAPAL, PBPBL, PCPCL. This just means keep going all the way back till I see something that isn't a lowercase letter. So where's the first thing that isn't a lowercase letter? It's this. And which capital letters do I want? This is a capital letter. So which capital letters do I want it to be? I want it to be an A or a K. What does A or a K correspond to? An A or a C. So that means this, where I originally said it could have been any capital letter, I realized it can only be an A or a K, which means it was originally an A or a C. So my first answer is A or C, A or B or C star, A or B, A or C. Okay, so now let's do the green path. So now the green path says the same thing, right? So I'm in state Q. In order to do the green path, you need to go to Q to T. So there again, there are three states that take me to T. So I'll just write A or B or C. All of them do something different. So there's some capital letter here, but I don't know which one because I haven't specified. And regardless, I go to state T. So now in state T, I have this loop right here. And that means that it could be an A or a B or a C star. Any number of characters. And then eventually in state T, I'll see a blank. In state T, if I want to, if I see a blank, I do this transition here, which says go to the left and go to state S. So I go to the left and I'm in state S, looking at the last character. And my goal is to go from state S to state X. So in order for me to go from state S to state X, I need to see a capital letter, a capital A or a capital K. So how do I, from state S, look at a capital letter? Well, there's only one capital letter. It's right here. So that means state S can't be looking at this symbol here. This symbol has to be this symbol. What that means is this star was equal to 0. Right? Essentially, the tape looked like this. Some capital letter and then blanks. That way in state Q, when I saw a letter, I changed it to a capital letter and moved to the right, went to state T. State T saw a blank, moved left, went to state S. S looked at this and saw a capital letter. So there's exactly one character here. And now I generically wrote A or B or C, but which capital letter do I want? I actually want an A or a K. An A or a K corresponds to an A or a C, so this is actually just an A or a C. And thus that's the answer. Union. Right? Left side, the right side, and the green path and the pink path. Are there any questions? Cool. Can you do part D or E? Input a finite state automaton and a Turing machine does F accept all states at which T halts. This is just the halting problem. This is theory. I don't really teach theory. String W exists in sigma star. Does Turing machine halt on W? No, this is also, you can't construct an algorithm to do this due to Rice's theorem. So you would write something similar to this here. But I could be wrong. I don't actually know any of this stuff. Okay, let's move on to the next question. Wow, it's a fun one. Okay, so let's try this one. Okay. Okay, so that'll be satisfying all four of these things. So the length of the string is equal to 6n plus 3 for some positive natural number greater than or equal to 1. So we need 6n plus 3 characters, right? And says the first leftmost symbol is an A. If the first symbol is an A, then the middle symbol is a B. If the first symbol is a B, and then the last symbol is a C. If the first leftmost symbol is a C, then the three symbols in the middle, form a palindrome. So like these three here. So 3. Okay. So we need to know where the middle is at every question, right? So for this, this is 3 separate questions. All right. And so let's just figure out how to write this thing here. And then, so starting from S, we'll have 3 separate regular expressions, 3 separate grammars, right? One for this one for this one for this one. So we'll call it A or B or D. So let's do A, right? A says the first symbol needs to be an A, the middle symbol needs to be a B, and then there needs to be an equal number of characters here and here, and then there needs to be a random character here. And so that way we know where B is, right? That way B is always in the middle. So how do we make sure this is always 6n plus 3, where n is greater than or equal to 1? That means we need at least 3 characters here, 3 characters here, and then 1 character here. And these could be anything. And then this could be 3 plus. So that just means it has to happen once. Okay, so let's call this A. All right, so the first symbol is an A. Okay, and then we need 3 characters here. And then this will be the middle. So this will be A, and then we'll need 4 characters. Okay, no. Okay, this can only happen once, right? Because we need this here once, and then every time after it can happen once. Okay, so let's add the 3 characters here, and then let's add another variable E, and then 4 characters here. So the reason we're doing this is these are the 3 characters that are here. These are the three characters that are here. This is the one character that's here. And then this is the A that has to be in the beginning. And then E will be our recursive part. So let's just write Z, right? Z can be any letter, A or B or C. And so that'll resolve that. E has to have a base case of B in the middle, right? And then what's the recursive statement? The recursive statement is the 6n part, right? So how do we have 6 characters? We always then do Z, 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 E, Z, Z, Z. Now this will always produce 6n plus 3 characters. So that's the first part. Now we have to do this again for the second one. Right, the second one is B. B has a B in the front and then a C in the back. And then we need 6 characters. 1, 2, 3, 4, 5, 6. And then again, we'll need something to keep reducing stuff in the middle. So let's call this F. Right, F will handle the recursive part. And F says, well, F can keep reducing characters. And then our base case is the middle character, whatever this character will be. So again, we have 3 characters here, 3 characters here, and then some random character here. All right, and that one random character will be a Z. And so that's that for this middle path. And then for the last path, D, well, we have C in the front. And then we need the middle 3 characters. Okay, so that means this is the middle 3, which means there has to be one character here. And this needs to follow the 6n plus 3. Right, so how do you do that? Okay, I'm gonna cheat. I'm just gonna look at our answer. Okay, A, 2, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is fine. They're both the same. I care about the K part. K says 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, the okay. Okay. So how do I do this then? So I do ZZ. And then I could repeat F. Is that what that's saying? No, I should just use a different variable. F, call it H, then Z, Z, Z. So 3 characters here, 3 characters here, and then keep repeating it. Oh. So this is part of the 3. This is part of the 3, and then this is the middle 3. And then the recursive parts will happen here at intervals of 3 also. Okay, that's easy. So 3 characters here, 3 characters here, and then H will just be Z, 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 H, Z, 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 4. And then our base case is these 3 characters that have to be a palindrome. So A, Z, A, B, Z, B, and C, Z, C. The reason you do this as a palindrome is because it's not a palindrome. So the middle character doesn't pair up anything, so it could be anything itself. But the other characters need to be palindromes, so therefore they need to be the same. And then this is our answer. It's slightly different than the way she did it. But yeah, they're both the same. This question is not fun. Okay, let's see what else there is. This is just exam 1 stuff. For sure this is all, okay, this is exam 2. I can do this one. Okay, we can do this one. Oh wait, this is the same question we just did. Okay, we can do this one. This one doesn't look bad. This is just a Turing machine. Okay, so let's start with figuring out the transitions. Q. So Q can go to X, or it can go to Y, or it can go to P, or it can diverge, right? As Q blank R. So in state X, you have a loop, and then you go to state S. In state Y, you have a loop, and then you go to state T. In state P, you diverge. In state S, you can go to state Z. In state T, you can go to state Z. Z is our final state, so therefore this is L accepts. Does she ask you to diverge? Oh, reject. But it just says write 8 distinct strings, not the regular expression for it. Okay, rejects is kind of annoying for this question. But there's 2 ways to reject. And that's in state S and T. So this is L rejects. This is L rejects. You can't halt in state Q or state X because they keep moving until you hit a blank and then leave the moment you hit a blank. So therefore these are fine. And this is diverge, this is diverge, this is accepts. And so we can do that. So which part did you want help with? Who asked this question? Whoever asked this question, which expression did you have trouble with? Rejects. Okay. So there are 2 ways to reject. Right? There is reject through S, and then there is rejects through T. So let's start with T. And so in order to reject from T, we need to go to state Y. So in state Q, how do we go to state Y? That means there's a B on the tape. So this B here has to be here. And then in state Q, if I see a B, I go to the right and I go to state T. Right? T has an A or a B or a C star, right? Oh, sorry, not T. We're going to state Y. Right? In state Y, Y is an A or B or C star, right? These 3 transitions represent the star. And so we keep looping towards the right until we hit a blank. So this is an A or B or C star. So in state Y, and I see a blank, I go to the left and I go to state T. All right, in state T, I can handle a Z, an A, right? A will get me to accepts, but I don't want to see an A, right? My goal is to reject, which means this needs to be anything other than an A, which means it can be a B or a C. Also, there's this B here. So B alone also rejects. So the first thing is B, A or B or C star, and then B or C. But then we also see that B rejects also, right? Because remember from T, I could be looking at this left character, but this left character might not exist, right? Remember, it comes from this star. And if this star is equal to 0, then this character is actually this B here. And in which case, this was never here. And then all that was left was just the B. So that's why there's an or B. And that same pattern will follow for when we do state rejecting at state R. Sorry, state S. So in state Q, my goal is to get to state X. The only way I do that is with an A. That means this A has to be on the tape. So I'm in state Q, I see an A, I move to the right, I go to state X. Then state X has a loop, right? This A, XA, XAR, XB, XBR, XC, XAR. This is an A or B or C star. And then the only other thing X can see is a blank. So then when I see a blank, I move to the right, the left, and I go to state S. Now state S wants to halt on a B, but I want to do anything else other than a B. So that means an A or a C. Because if I'm in state S and I see an A or a C, then I'll halt because state S doesn't have anything to do with that. And if state S is not my final state, therefore it rejects. So we have A or B or C star, and then A or C. But again, if there was only a single character on my tape, none of this, the star was equal to 0, this S would actually be looking at this A. Therefore, A is also a reject string. This question doesn't have an answer key to it, so I don't know if I'm correct. Can someone confirm if I'm correct or if I missed something? $13. It just doesn't have. Nice. Okay, we have an answer key. Okay, this is A union B or B, or A or B or C star B. Yeah, okay, we got it right. Nice. right? See, we got it right. We're smart. Okay, cool. We answered that one. This is from a recent exam, from our recent exam. Well, if it was on your recent exam, it's probably not going to be on your final. So probably not worth studying. But I'll do it anyways. So start with the transitions. So Q, 3 transitions go to B. 2 of them replace it with a capital letter, so let's keep that in mind. Okay. And Q has a Q blank R, so this is also a null rejects. I lied, and null diverge. And now, what is this? A P. In state P, I have PB, PBR, PC, PAR, PA. Oh, did she have a stroke writing this? This doesn't even do anything. PA, right, left, V. Oh, I see. Oh, this is not. What is our final state? Our goal is to halt. Okay. Okay, so let's do this one at a time. So blank and then A. So there's no way to halt in P. P moves forwards and backwards, like left and right. So that's confusing, right? But it also goes to V, and then in V it goes back to P. Right. So basically, notice here it says if I'm in P A V capital A L, then I go to the left, and then V says if I'm in capital A, I go to a P. And then, so you can be going back and forth in between these states. So let's figure out where we even want to halt. So we can't halt in state Q. So the way you do this is going to the right, you check for everything in the alphabet and blank. And then going to the left, you check everything in the alphabet and go and all capital letters. So like gamma, like the capital letters. Let's call it X. Right. P does both. So I need to check if P can hold on anything in the alphabet, any capital letters or any blanks. It happens to do everything, right? So it does blank, does any lowercase letter, and does a capital letter. And then V only sees a capital A, which means V, and we enter V through the left, which means we need to enter V looking at a lowercase letter. So we need to see in state V, we can alt. Okay, she says LT on either an A or a B or a C. So we need to figure out how to do that. Get to state V and alt on a lowercase letter. Okay, so let's try. Let's go straight to the regular expressions. So we're gonna skip A and B. And now this says halts. So here we need to figure out a way to see an A or B or C. Okay. So starting from Q, we need to go to P, which means we need to do one of these 3 transitions. Either Q, either see an A, a B, or a C. Also, either one of those things might keep the letter the same, or it might turn it into a capital letter. So we'll figure that out if we ever have to look back at this thing. We'll be more specific there. But for now, it's something. It's not empty. And then we go to state P. And then in state P, we have this left here, but we have this B PB PBR. So we could have a B or C star. Those all write something on the tape. And then also A's are ignored, but A's are lowercase a's. So there's an A or B or C star here. So all A's are turned into capital A's. And then capital A's are kept capital A's. All C's are turned into capital A's. And the only thing that's not turned into a capital A is a B. So B is probably the only way that we'll be able to leave. But the other difference is C and A do two different directions. A goes to the left and B goes to the right. And we go to the left and then go to state V, and then V will need to see a lowercase letter. But all A's get turned into capital A's, so this can't halt here, and all C's get turned into capital A's. So that means we need to enter on a B. So that means the B needs to be left of an A. So we need to figure out a string that has BA in it. The reason being, when I'm in state Q, when I'm in state P, I see a B, I'll go to the left, I'll go to the right, and then I'll be in state Q. Sorry, in state P again. Then in state P, this will turn this A to a capital A, and then go to the left in state V. And then in state V, I'll see a lowercase letter and I'll halt. So B is the only lowercase letter that doesn't get changed. So that means this BA needs to exist somewhere in the string. That's the only requirement, actually. Right? Because this going back and forth from the left means we can have a star on either side. So this star that we have here exists on the left and on the right of this BA. Because we can enter P from the left or from the right. Right? So we can go to state P from here or from state Q. So therefore there will be a star on this side and then a star on the side because P itself has a P, A or B or C star. This A or B or C star comes from the A's being, the capital A's being A's. And then anytime you see another A or a C, you just turn those into capital A's. But those don't actually change anything because they still correspond to the same letter. The only time they matter is if a B is before it, because that's how we'll halt. So there has to be a BA in it. And so this can then be an A or a B or a C star. And this can be an A or a B or a C star. And then, so that's halting. But in state T, oh, this is just a state transition graph. It's not even asking for diverges. Okay, converting this into a state transition graph is simple. There's a loop in the beginning. And then we need a B for that first thing, and then an A. And then there can be another star. And then this will be our final state because that's all. So this question wasn't that easy. This was from your second exam. Yeah. I'm pretty sure I told you guys in the last review that to not study Turing machines, that if you should just spend all your time on pumping lemma. But I went over Turing machines anyway, just in case you didn't want to miss out on those points. But this was a pretty hard question. Okay. So if there aren't any more questions, I'll we'll give 1 more minute for questions. Broke out the old Brennick version of paper. Why is this black? The way you answer any of these is if they're the complement, all final states become starting states, and all non-final states, and then non-final states become final states. So like for example, B here, the final states are 0, 1, and 4 plus. Here you just have 2 and 3 as your final states, and everything else becomes non-final states. The transitions don't change. For this one, I don't know why it's necessary to add this garbage state here and not here. So technically there should have been a garbage state here where there was like a transition leading from the final state to another state, and then that state just having an A or B or C start loop on it, but not being a final state. And then it would make sense that you can just convert this to this by switching the states. That's all you have to do. Yeah, it's because Obernik likes to wear black. Okay. Cool. All right. Well, seems like that's all. So, what is Rice's theorem? Can we practice a pushdown question? If you send a question, I can do it. But if you just ask, no. So someone told me that you won't have pushdowns on your final. So why do you guys want to study it? I can do this one if you want, but it doesn't seem like it's a good use of your time if it's not going to be on the final. The way pushdowns work is they have a stack. This is a FIFO stack, LIFO stack, last in first out, right? So elements at the bottom. So this would be the first element, the second element, the third element, the fourth element entering, but this would be the fourth element, the third element, the second element, the first element, and leaving. Right? The stacks, simple, cool. Now, these symbols here, the way you read it is, this is this, so Q, B, lambda, Q, bub. So this is the state you're in. This is the state you go. This is what you write. This is what you pop off your stack. And this is what you push on your stack. So for example, you start at state Q, and and our goal is to get to a final state. with an empty stack. If we get to a final state with an empty stack, then we're done. That's it for our question. But not all pushdowns you can write a regular expression for. Some of them you can't. And if you can't, you can definitely write a context-free grammar out of them, but you might not always be able to write a regular expression. So therefore, it's good to just draw out like templates and use that to create the answers that you need. So for this question, we're in state Q and we have two transitions where both of them pop nothing off the stack. So that means they cost us nothing to do. But this top one actually does something, right? And it keeps us back in state Q, right? We start in state Q, we write a B, we pop lambda off the stack, so pop nothing off the stack. We go to state Q and we write B on the stack. So what we can do is we could do B, and then we'll write a lowercase b, right? But we could do this any number of times, right? We could have done this n number of times. And if we did this n number of times, we would have n number of b's on our string. All right, so these are all, there's b to the n number of letters on our stack, and then b to the n number of letters on our string, right? These eventually will be converted into symbols on the tape, on our string, but for now they're capital letters on our stack. And so we've done this top transition a number of times. We don't really want to do it anymore. So the only other thing to do is do this other transition that says if I'm in state Q, write nothing, pop nothing, go to state T, push nothing. So just free transition to state T. So now we went from Q to T. And then in state T, it says, if I'm in state T and so we're gonna do this first T transition because it keeps us in T. The second one makes a transition straight to S, so we're not gonna do it yet. We're gonna do this top one here. So in state T, we can write a D, and then we can push AA on our stack. Again, we pop nothing off our stack. So we have AA on our stack. And then we could do this any number of times. Say we do it M times. That means we will have M number of Ds on our string. And the moment we do this next transition, so we're done doing this transition. We've done it M number of times. We don't want to do it anymore. So this T, this other T transition says, if I'm in state T, I can write an E. I can pop nothing off my stack, go to state S and push nothing on my stack. So that means there's just an E on our string. And now in state S is our final state, but we can't end right here because our stack isn't empty. So we need to get rid of characters on our stack. And luckily we have two transitions, one that'll cost us A's and the other one that'll cost us B's. And we only have A's or B's on our stack. So if I'm in state S and I see a C, pop an A off our stack, go to state S, and then push nothing on our stack. Right? So what's at the top of our stack? Remember, this is a stack, so LIFO. So whatever's at the top is what we have to do. We have A's at the top of our stack. How many A's do we have? We have M of them. So we have to do this operation, well, technically 2M times, but we'll just link these together as C's, right? So C to the M. And then this will be A to the N. Notice these are linked together, and then these are linked together, because these are directly related to how many times we wrote them and pushed something onto our stack. And then the moment we've popped all of them off, they're gone. So now our stack is empty. We're now in state S. S is our final state. Therefore, this is our answer. And now how do we write this as a context-free grammar? Well, actually, I should write it like this: B to the N, D to the M, E, C to the 2M, and then A to the 3N. Now this is a lot more readable, right? So now we just have coefficients in the front, constants in the back. There are no constants for any of these. And then there's just an E in the middle. And so this is our template that we get. And then this is how we would solve it. Just basic calling this S, calling this A, right? S has one B in the front, three A's in the back. And then our inside part is just A. A is one D in the front, two C's in the back, and then our base case is an E. Just whatever's in the middle. And that's it. So pushdowns are quite easy. But they're probably not going to be on your final if she doesn't teach it. Okay. Sounds good. I'll if there are no more questions, I'll end the recording here.